Student expectation. The student applies logical reasoning to justify and prove mathematical statements. Basically, what this means is that the student will use common sense to see whether or not something is true. Now we're going to be talking about conditional statements. This includes its validity, converse, inverse, and contrapositive. The statement, "If Dustin wears the wig, then it is Sunday," is a conditional statement and it is true. The part of the sentence following the word "if" is the hypothesis, and the part after "then" is the conclusion. The converse of this statement is the switching of the hypothesis and the conclusion. So if the original statement was represented as "if P, then Q," with P as the hypothesis and Q as the conclusion, then the converse is represented as "if Q, then P." So the converse is, "If it is Sunday, then Dustin wears the wig." We can determine that this is true because we know that in the original conditional statement, which is true, it was said that if Dustin wears the wig, then it must be Sunday. So it is true that if it is Sunday, Dustin will be wearing the wig. The inverse is the opposite of the conditional statement. Originally being "if P, then Q" changes to "if not P, then not Q." So the inverse is, "if Dustin is not wearing the wig, then it is not Sunday." This is true because we know that Dustin wears the wig on Sundays, so if he is not wearing the wig, then it is a different day. The contrapositive is a switching of the opposite of the conditional statement, or the switching of the hypothesis and the conclusion in the inverse. Originally being "if P, then Q" changes to "if not Q, then not P." So the contrapositive is, "if it is not Sunday, then Dustin is not wearing the wig." This can be proven true because we know that Dustin only wears the wig on Sunday. So if it isn't Sunday, he won't be wearing the wig, if he stays true to his word. Let's do an example problem. If the probability of an event is 0.1, then the event is unlikely to occur. This is true. The converse would be, if the event is unlikely to occur, then the probability of the event is 0.1. This is false because the probability could be 0.01 and still be unlikely to occur. The inverse, if the probability of an event is not 0.1, then it is not unlikely to occur. This is also false because, again, the probability could be 0.01 and still be unlikely. The contrapositive, if the event is not unlikely to occur, then the probability is not 0.1. This is false too, because the probability could be 0.01 and it would still not be likely to happen. Conditional statements can be implemented into real-world scenarios using logic chips. Logic chips are similar to conditional statements in that they require two inputs and give one output. In conditional statements, if one part is false, then the statement is false. This is how logic chips are designed. The two inputs can either be true or false, or a combination of the two, and if one piece is false, then the output is false. If you would like to learn more, information about conditional statements can be found in Chapter 2, pages 74 through 90 in the geometry textbook.